Introduction. The Pharmacy Unit Kesihatan is located at UiTM Sawangan, Kelantan, Jalan Cordova, 18500 Bandar Macam, Kelantan. It is managed by UiTM staff and provide medical service to all UiTM students. The current problem is the pharmacy struggles to manage a large amount of staff and patient data. The current system is manual and not organized. This manual process take a lot of time and lead to mistake, and we need a database system. First is to make a process faster and more efficient. Second is a reduce error, and third is improve data management. With a database, the pharmacy unit can first is manage information about staff, supplier, department, drug and patient better, and the second is meet current and future needs effectively. And the conclusion is a database system will solve the current problem and make the pharmacy unit kesihatan more efficient, and this will lead to a better service for UiTM student.
Next is our objective of the system. Our first objective is to develop UiTM Macam Pharmacy Unit Management. Secondly, our objective is to calculate the prescription record of the expired date medication stock. Third, our objective of the system is to update the patient data about phone number. Next, our objective is to sort the output according to department name. Lastly, our objective is to sort the data descending for medicine expired date.
Okay, for current system description, in today's healthcare environment, effective pharmacy data management is essential for quality patient care, medication safety, and operational process optimization. A pharmacy database system serves as the backbone for storing, organizing, and retrieving critical information related to medications, prescription, patient profile, inventory management, and regulatory compliance. The goal of this project is to develop comprehensive pharmacy database system that improve the efficient, accuracy, and safety of pharmacy operations and facilitate seamless communication between healthcare provider and patients. Okay, for this AID, we have entity and attribute. First, department attribute is department number. For there is a primary key for department, and we have department name, department phone, and employee ID for each key. Okay, the next level is employee attribute. We have employee ID, primary keys, employee name, employee age, and employee gender. Patient, we have attribute for patient ID for primary key, patient name, patient age, patient gender, and patient address, and patient phone. For the next, we have medical record attribute. We have medical record number, primary key, medical record type, medical record treat, and medical record take, and patient ID for foreign key. Okay, next we have the medication attribute is medication code, primary key, medication name, and medication in medication expired. Patient medication attribute patient ID, primary key, foreign key, medical code, medication code for primary key, foreign key, dosage unit, and frequency. Okay, next for relationship department and employees. A department employs one or more employees. Relationship employee ID in the department entity is a foreign key that links to employee ID in the employee entity. Next, we have employee and patient. An employee dispensing medication to patient. Relationship is implied through the interaction between the employee and patient entity. Patient and medical record. A patient owns one or more medical record relationship. We have patient ID in the medical record entity is a foreign key that links to patient ID in the patient entity. Okay, next we have patient and patient medication. Patient is prescribed multiple medication relationship. Patient ID in the patient medication entity is foreign key that links to patient ID in the patient entity. And next we have medication and patient medication. Medication details are linked to the patient medication entity relationship. Medication code in the patient medication entity is foreign key that links to medication code in the medication entity.
5.0 Data Definition Language. First, we need to create a database for pharmacy. So the database name is pharmacy. Create database pharmacy and use pharmacy. Next is for table name employee. First is a create table employee, and next is employee ID numeric 10, primary key not null, employee name Wacha 20 not null, and employee age numeric 3. Next is employee gender boolean, a female or male. Next is a table name department, a create table department, depart num char 6, primary key not null, depart name Wacha 20 not null, and depart form Wacha 12. And next is employee ID numeric 10 not null, constraint FK department, employee, foreign key, employee ID, reference, employee ID.
Okay, for the table fashion, we must do create table fashion, and we have fashion ID number 6 not null, fashion name Wacha 50 and not null, fashion age number 3, fashion gender Wacha 6, fashion address Wacha 50, fashion phone Wacha 12 not null, primary key, fashion ID. Okay, for the table medical record, first we have to create table medical record. Medical record number numeric 10 not null, medical record type Wacha 20, medical record tick Wacha 20, medical record tick Wacha 30, patient ID numeric 6 not null, primary key, medical record number.
Next, we create the table medication to record the data for type of medicine. First step is we type create table medication to create the table. After that, state all the attributes and the data type for the attribute, which is medical code, we use numeric 3, medical name we use Wacha 20, medical in and medical expired we use data date. Then we need to state the primary key for the table, and for this table, the primary key is medication code. After that, we can insert all the data for the table, and the last outputs will be like the table beside. Next, we need to create the bridge table for patient and medication, and we name it as table patient medication to record data of patient medication history. First step is we type create table patient medication to create the table. After that, state all the attribute, which is patient ID, medical code, dosage unit and frequency, and we state all the data type after the attribute. Next, we state the primary key used in the table, which is patient ID and medical code. We also need to state the foreign key used, which is patient ID from table patient and medical code from table medication. After that, we can insert all the data for the table. The last output will be like this.
6.0 Data Manipulation Language. First query and question is list all medication numbers and name along with their stored in and expired date. And for SQL answer is select med code, med name, med in, med expired from medication, and we can see the output. For next query question is update latest patient's phone number, and the SQL answer is update patient, set patient phone equal to the number phone, where patient ID equal to the patient ID that we want to update their number phone, and we can see the output. The correct question is list medications sort by their expired date in descending order. For the SQL answer is select med code, med name, med expired from medication, order by med expired test is for descending, and we can see the output.
Next, for the data manipulation language, I will give the example for fourth and fifth question and solution. The fourth question is list all the medical record for a specific patient. In the SQL, we type select medical record number, medical record type, medical record treat, medical record date from medical record, where patient ID is equal to 5208, and we get the output like this. For fifth question, display all the name of employees start with N. So the need for this question is to display the employee name from table employee who start the name with N. In the SQL, we need to type select employee name from employee, where employee name like N%. In the output, we will get two names start with N, which is Nur Kalsum Mujahid and Nur Adibah Yusri.
Okay, for the conclusion, our pharmacy management system (PMS) make pharmacy operation more efficient and equipped by automated tasks like inventory management, prescription processing, and billing. They reduce manual work and errors, allow pharmacy to focus more on patient care. The system tracks stock levels in real time and automatically reduces supplies, preventing shortage and excess inventory. It also enhances patient safety by alerting for drug injection and dose issue and keep detailed patient record for personal care. Automating billing and insurance can save money and improve financial management. The PMS product useful data insight for better decision making and service improvement, leading to higher customer satisfaction and loyalty. Future advancements like telepharmacy, mobile apps, and artificial intelligence will further improve pharmacy management. Overall, PMS boosts efficiency, safety, and healthcare outcome. Implementing a PMS at Unique Setam UITM will significantly enhance its operational efficiency, reduce better patient safety, and improve care service for students and staff.